Imagine slipping on a sleek headset and instantly stepping into a world where your physical and digital realities merge flawlessly. Not years from now, today. Spatial computing is no longer science fiction, it's happening, and it's transforming how we interact with technology at a fundamental level. What's behind this revolution? Magic leaps, breakthroughs that blend artificial intelligence, advanced optics, neural sensing, and spatial awareness into immersive experiences that feel like actual magic. Before we dive into how this tech is evolving faster than anyone expected, do us a favor. Hit that subscribe button, click the notification bell, and like this video. It helps more than you know, and keeps you looped into every future-forward breakthrough we explore. Let's break down what spatial computing really means. At its core, spatial computing allows digital content to exist and behave as if it's part of the real, three-dimensional world. It combines computer vision, sensor fusion, edge AI, real-time environment mapping, and intuitive gesture tracking. Your device no longer just shows you content, it understands your space, interprets your body language, and anticipates your needs. Think of Apple Vision Pro, Meta's Quest 3, and of course, Magic Leap itself. But this is more than hardware. It's a tectonic shift in how we live, learn, work, and create. Take Apple's Vision Pro. With ultra-low latency eye tracking, hand gesture control, and spatial awareness, it turns any environment into a workspace, cinema, or creative studio. Apple's approach is less about gaming and more about making spatial computing an extension of your daily life. From reading emails on floating screens to collaborating with colleagues around virtual prototypes. It's Apple's attempt to redefine the personal computer, again. Meanwhile, Meta's Quest 3 leans into mixed reality gaming, merging digital elements like portals, weapons, and creatures into your living room. It maps your surroundings in real time and creates shared experiences across users, no matter where they are. The headset offers high-fidelity pass-through video, meaning you can see your real environment clearly, overlaid with digital content that reacts to your body and your surroundings. This is gaming that doesn't just react to your inputs, it reads your room, your actions, and your attention. And then there's Magic Leap, the company that brought spatial computing into the spotlight years ago. After a major pivot from consumer hype to enterprise utility, Magic Leap 2 is now powering surgical guidance, remote collaboration, and industrial training. It uses advanced light field displays to project depth-accurate, persistent virtual content that feels solid and real. These companies aren't just building headsets, they're laying the foundation for the next major computing platform, one where the screen becomes the world around you. But the magic doesn't stop at display hardware. One of the most jaw-dropping leaps is happening behind the scenes, inside the processors and AI models that power these experiences. Spatial computing depends on understanding the environment in real time. That means millisecond-level tracking of depth, motion, lighting, and user intent. Enter Apple's R1 chip, a new processor designed specifically for sensor fusion. It handles 12 cameras, 5 sensors, and 6 microphones simultaneously to build an accurate 3D model of your world. Meanwhile, Qualcomm's Snapdragon XR2 Gen 2 chip supports 4K per eye resolution, dynamic spatial audio, and AI inference right at the edge. In plain English, you get ultra-responsive, photorealistic experiences without lag or disconnection. And it's not just about what you see, it's how the system sees you. Eye tracking and neural inputs are becoming central to control systems. Instead of reaching for a controller, you simply look at what you want to select and tap your fingers. Your eyes are the mouse, your fingers the click, and your room is the desktop. This kind of intuitive input is a massive shift in how we relate to machines. It lowers the learning curve, makes tech feel more natural, and opens doors for people with physical disabilities to interact with digital environments in new, empowering ways. For instance, spatial computing allows users with limited mobility to control interfaces using only head movement or gaze. These breakthroughs aren't just convenient, they're life-changing. Now consider what happens when this technology goes beyond novelty and into critical workflows. Architects can walk through buildings before a single brick is laid. Surgeons can rehearse procedures with real-time anatomical overlays. Engineers can troubleshoot machinery remotely by collaborating through spatial annotations. This isn't the metaverse hype cycle, it's already in deployment. Lockheed Martin uses Magic Leap to assist technicians on complex aircraft systems. Siemens is integrating spatial computing for factory planning. and doctors at UC Davis are testing immersive patient education modules using volumetric scans projected in 3D. These use cases save time, reduce errors, and deepen understanding in ways flat screens never could. Education is another frontier. Imagine students studying history by walking through ancient Rome, not reading about it. Chemistry students manipulating molecular models mid-air. Art students sketching in 3D surrounded by references. Learning becomes multisensory, participatory, and endlessly customizable. It also levels the playing field. Students in remote areas can access immersive, guided learning environments that feel on par with top-tier institutions. In retail, this means trying on clothes without undressing, walking through a furniture store with products projected into your own living room, grocery shopping with recipes and health data hovering in your field of view. In logistics, warehouse workers equipped with spatial overlays can pick, scan, and pack items without needing to look at paper or phones, reducing errors and improving speed. And hey, if you're excited by how fast this space is moving, take a second right now to like this video, subscribe if you haven't already, and drop a comment below with what part of spatial computing you're most curious about. Your engagement helps push this kind of content to more tech lovers like you, and it tells us what to decode next on Tech Mythos. There's also a bold move toward expanding spatial computing into untethered experiences, smaller glasses, lighter hardware, and longer battery life. Researchers are experimenting with retinal projection systems and adaptive lenses that change based on where you're looking. Apple has filed patents for smart contact lenses. Meta is investing in neural wristbands that interpret your nervous system directly, no headset required. Magic Leap continues refining its waveguide optics, aiming for thinner, more comfortable wearables that could one day replace smartphones entirely. And while we're focused on immersive visuals, spatial computing isn't only about what you see, it's also about what you hear. Spatial audio is becoming a critical component of believable experiences. Audio cues can signal the location of digital objects, make conversations with virtual characters feel real, or guide users intuitively through digital spaces without visual clutter. The fusion of auditory and visual feedback increases immersion and accessibility, especially for users with visual impairments. In the workplace, spatial computing transforms how we collaborate. Instead of video calls, teams meet as 3D avatars in shared virtual spaces. Brainstorming sessions happen on infinite whiteboards that float in the air. Documents and datasets can be pulled apart, annotated, and manipulated like physical objects. Microsoft's Mesh platform and Meta's Horizon workrooms are early examples. But the real breakthroughs will come when spatial computing becomes device-agnostic and cloud-synced, letting users jump between devices and locations without friction. Healthcare is also being transformed. Beyond surgical planning, spatial computing is being used in mental health applications, creating calming virtual environments for therapy, or simulating exposure scenarios for patients with PTSD. In physical rehabilitation, spatial overlays help patients visualize progress and receive real-time feedback on movement. Startups like XR8 Health and Applied VR are pioneering these experiences, and early studies show improvements in pain management and emotional regulation. Urban development, too, is being reimagined. Spatial computing lets planners visualize how sunlight hits new buildings across seasons. Traffic flow, noise levels, and wind patterns can be simulated in real time. Digital twins, 3D replicas of physical cities, enable simulations of everything from disaster response to green energy implementation. This is more than visualization, it's decision-making powered by immersion. And let's not ignore art and entertainment. Immersive theater is being reinvented. Virtual concert halls adapt based on audience mood. Museums integrate spatial storytelling that evolves based on where a visitor stands. Imagine a digital painting that responds to your heartbeat or a sculpture that changes form as you walk around it. Spatial computing becomes a canvas, not just a display, but with great magic comes serious responsibility. These systems collect unprecedented amounts of data: your location, movements, facial expressions, even biometric signals. What happens when advertisers tap into your gaze patterns? Or when employers analyze body language for productivity? We need ethical frameworks that match the power of this technology: consent-based, transparent, and user-controlled. Regulation must evolve in tandem, not years behind. And yes, it raises deep philosophical questions. What happens when the digital world becomes more compelling than the real one? Will we lose touch with physical connection, or will spatial computing deepen our appreciation of it? The answer depends on how we design these systems, not just for convenience, but for human flourishing. The most powerful spatial computing systems won't replace human experience, they'll enhance it. Despite these concerns, the trajectory is undeniable. Every leap in display, processing, connectivity, and AI integration brings us closer to a world where technology dissolves into our surroundings. We won't talk to computers. We'll talk to our space. The tools we use will be ambient, anticipatory, and adaptive. This isn't just computing, it's coexistence. So where are we headed? Toward a world where the digital and physical coexist fluidly. A world where workspaces, art, entertainment, and relationships unfold not within screens, but around us. And with every leap, whether from Magic Leap, Apple, Meta, or the startups building next-gen optics and AI, we step closer to making the invisible visible. The age of spatial computing isn't coming, it's here, and it's magic. And let's dream even further. Imagine your home adapting in real time. Not just smart devices turning on and off, but ambient experiences that shift based on your mood, your intentions, or the people present. Spatial computing could personalize lighting, music, temperature, and even decor dynamically. Want to meditate? Your space dims, a calm landscape appears, and soft spatial audio guides your breath. Hosting a party? Your environment pulses to music, reacts to movement, and displays social highlights. It's architecture and computing converging into living, responsive environments. The applications in sustainability are equally profound. Spatial sensors can detect energy waste in real time and offer intelligent suggestions or auto-corrections. Citywide systems can adapt lighting and traffic based on real-world activity. Green buildings will no longer just be structures, they'll be smart, self-regulating ecosystems powered by real-time spatial intelligence. Want to stay ahead of the tech curve? Hit that subscribe button and turn on notifications. At Tech Mythos, we decode the future, one breakthrough at a time. If this blew your mind, drop a comment, share it with a friend, and don't forget, this is just the beginning.